support for native code. So people could bring PHP, for example, onto the platform. People could bring native C++ code onto the platform. We added admin mode, so people could bring code that wasn't designed to work as standard user. We added startup tasks to the model so that you could say, I've got an install program that installs a bunch of libraries my program uses, and I need, when my package gets deployed, for that install program to run, and run with administrator rights. We added RDP. One of the original viewpoints of Azure was debugging should not be interactive. When you're writing cloud scale, it should be emitting monitoring data that you go and debug from that. Very rarely or never should you have to terminal server into a VM and diagnose the problem there, because that just doesn't scale. But we added it because people demanded it. Then what we ran into was that customers that we went and talked to, especially enterprises, which one of Microsoft's strengths is our connection with the enterprise and our on-premise assets like System Center, Virtual Machine Manager, and Configuration Manager, is that our customers would say, look, we buy the platform as a service thing, and we love the model, and we see the benefits of it even as we've created some new apps for our environment, put them up in Azure, we see the benefits. But we've got a whole bunch of assets that we also want to move to the cloud, and those things are server applications, and we can't rewrite them, or it'll take us forever to rewrite them. So what do? We can't put them on Azure. So should we go to a cloud provider for those, a different one that supports those? And if we do that, we're probably going to go to platform as a service on those too. So we were stuck. Like, how do we get people to onboard onto the cloud at their own pace? And for that, we realized we had to bite the bullet and develop infrastructure as a service, which is the big on-ramp. If you look at all the other things, they're incremental steps, but this one is the big one. Infrastructure as a service means we give you a VM, you put the operating system in it, you put the apps in it, and it behaves like a VM. Now, before I get into talking about the difference between infrastructure as a service and platform as a service, from Azure's perspective, let's go create a virtual machine in Windows Azure. So we'll go to the portal. For those of you that haven't seen this, those of you that have created virtual machines, this will be familiar to you, and hopefully my network is working, and for some reason it is not working. That'll make demos very difficult. Oh, maybe. Here it is. Okay, we're back. All right, so we've got a list of virtual machine images here in what we call the gallery, or the platform image repository we can pick from. And these are, I'll talk more about what these images mean in a second, but we can pick from a number of different operating systems here. Which one would you like to deploy? Let me scroll through here. We've got obviously the best operating system right here. We've got some other ones down here that are, in my opinion, not so good as that one, but reasonable. Actually, I'll pick this one just to surprise you, Ubuntu Server 13.04. It's a Linux image. And the network was working a second ago. Okay. It's going to be an interesting talk if I can't even show creation of a virtual machine. Have people been running into network problems in the presentations? Yeah, great. Okay. Any suggestions? This? Yeah. Here, let me try something. Don't look. And the portal looks just as good in these other browsers, which this one seems to be dealing with the network problem a little bit better for some reason. And let me try new. All right, virtual machine from gallery, and I was right here. Okay, we're doing a little better. All right, virtual machine name. Anybody have a suggestion for virtual machine name? Nobody? Nobody. Wow, this audience is just not participating. You're so stunned by the lack of my network problems. What? Why Linux? Yeah, that's a good question. Now we pick a username. I'm going to change it to my standard because we're going to use that later. And I'm going to say I want password-based authentication. We could use certificate-based authentication if I want to. Press next. And at this point, I get asked if I want to create a standalone virtual machine or connect this to an existing virtual machine. I'll explain what that means a little bit later. But for now, we're just going to follow the default and create a standalone virtual machine. And the next thing we get asked for is for a DNS name. I'll just give it the same name as I did for the virtual machine. Notice two different things, virtual machine name, DNS name. I get asked now where I want to deploy it. And since we're in Europe, I'll put it in Europe. And the subscription. I've got a few subscriptions that I've got access to through this login. I'm going to put it in this one. And then I get asked for an availability set, which I'll explain what that is a little bit later. And I'm done. Now I deploy. This operation is going to take approximately 3 to 4 minutes, and I'll have my virtual machine spun up and ready to go. And then we're going to go play with that virtual machine a little bit later. But that's as easy as it is to go and, using the portal anyway, interactively to go spin up a virtual machine. Now, what's the difference between a virtual machine like I just created and the platform as a service virtual machines? Has anybody deployed a cloud service, a PaaS cloud service on Azure? So you're familiar a little bit with that? The concepts of worker roles and web roles. These are VMs as well. They're a different flavor of VMs than the VM that I just created, though. And this chart shows you some of those differences. If you look, I've got 4 different categories there of attributes: storage, deployment, networking, and primary use. And you can see that, you can see that storage is the fundamental difference. Storage for an infrastructure virtual machine is persistent, is what we call persistent storage. So the application in the VM, when it writes to the host OS disk, when it writes to the registry, when it creates a SQL database there, that survives and matches the life cycle of that virtual machine. So it'll be there persistent until I delete or destroy that virtual machine. That's different than the platform as a service virtual machine storage, which you get with the worker and web role virtual machines, which is stateless. When we write from those virtual machines to the local storage, to the OS disk, you have to expect that that data is ephemeral, that it won't survive a life cycle event of the server that the VM is running on going down because the disk failed on it, because the motherboard failed on it, because the CPU failed on it. Because at that point, the VM will get reincarnated on a different server, a healthy server, and it'll have forgotten everything it did before that point. It basically starts with a pristine image of a brand new OS plus the application installed onto that OS. The state that it had written in its previous life back on the server that died is lost with that server. And that is the fundamental difference between the two, and why, if you look and think about a server application like SQL Server, why it's incompatible with platform as a service VMs. They write to a database, and they expect when I write to that database that for the life of that VM, if I go read, I'm going to read what I wrote. You can actually put SQL Server in a worker role. It's a complete waste of time because you write to the database, the server, and that database will be there as long as that VM stays on that server, which can be a very long time and might lull you into a false sense of, hey, this is actually working. But one day, that server is going to die, the VM will get migrated, reincarnated, and you'll have lost everything you wrote to that SQL database. So that is the fundamental difference, and you can see that there's some other differences here. Platform as a service is a runtime, And one of the characteristics of that runtime is name discovery. So when one virtual machine in a platform as a service application wants to discover another one, it does it by calling a runtime API and saying, hey, I know I've got a tier called the foo worker role tier. What is the IP address of instance 1 in that tier? Now, how do you do name resolution in a standard server application? You use what service? DNS, right. And so we didn't have DNS because we used runtime APIs. So that was another difference. And then you can see that there's some other differences. But the benefit of this PaaS model, by the way, shouldn't be forgotten. And in fact, I want to emphasize the point that we ultimately believe in platform as a service. That is the future of application development. The stateless scale-out model versus the scale-up stateful model that we've got from traditional server applications. The stateless one, it's very easy to write an application that is scalable and highly available because that case of one of the server failing, I just spin up a reincarnated version, and because it's stateless, I didn't lose anything. Any data that I want to persist, I externalize to something like Windows Azure Databases or Windows Azure Storage, and so my compute is very easy to scale out and be highly available. And that's very different than from, if you want to make SQL highly available and scale out, you know that it's pretty challenging. And I actually have got a scale out SQL Server installation. Painful to set up, painful to maintain, but that's the state of the existing server apps that we want to bring to the cloud. So let me talk a little bit about how we came to this, or what we decided as far as our feature set would look like for infrastructure as a service for this first release we had back in April. When we sat down, of course, Amazon already had infrastructure services. That's the way they started. And we said, we got a choice. We can go copy everything they do, which is a big, long list of stuff. Checkbox, 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 checkbox. Does Amazon do it? Yeah, checkbox, we do it. We decided that that was actually a path that would ultimately failure for us. Why would it be failure for us? Because we wouldn't be sure that we actually had an end-to-end platform that would enable the scenarios that customers, you guys, would want to have enabled. If we missed one checkbox or didn't fully check it, we might completely miss a whole set of interesting scenarios. So we decided instead, let's focus on enabling the things that IT wants to do, which is to migrate existing applications up into the cloud in a secure way. And this is the list of requirements we set out for ourselves as we developed our feature set. IT Pro Experience. No need to have to know XML to deploy. You saw me deploy a VM. I did not touch XML. I didn't open Visual Studio. If I want to do platform as a service, I've got to do those things. Support for key server applications. Well, if we could create VMs, but we said, well, we've got VMs for you, but you can't install any server applications in it. It's a violation of support policy if you put SQL in it. How useful would that be? Pretty useless. So we had to say, we need to make sure that we support these key server applications. Easy storage manageability. This is one place where we decided to differentiate from Amazon. You're going to see how many people have used EC2, by the way? Just out of curiosity, just a few of you. Well, they've got a kind of Roach Motel version of storage for VHDs. It's called Elastic Block Storage, and you stick your VHDs in there. It's almost impossible to get them out of there. We wanted to make it so that our VHDs are leveraging our platform as a service storage infrastructure, and so they're easy to move around, easy to copy, easy to migrate. You can use existing APIs. We invest in one infrastructure and get benefits for both our PaaS side as well as our IaaS side, and that's one of our goals. High availability features. We know that over time, people are going to put mission-critical workloads up into the cloud. Not doing it so much today. Very few people are actually doing that. Most people are right now dev testing in the cloud and maybe putting tier 3 line of business apps up in the cloud where if they go down, it's no big deal. Eventually, though, our whole infrastructures are going to be running up in the cloud. We wanted to show that we've got a vision, a roadmap to get there by introducing high availability support right off the bat. Advanced networking features, we know, if you saw the keynote, that having secure connections from your corp network up into the cloud is extremely important to even enable a line of business app that you don't want exposed out on the internet. And then finally, ultimately, integration with PaaS, which I'll talk very briefly about at the end of the session. Like I said, PaaS is the future. And so if we said IaaS without a thought for PaaS, we know that we would leave you guys without the future available to you. So one of the key aspects of enabling that future is allowing you to migrate from IaaS to PaaS over time at your rate, and make sure that IaaS and PaaS can integrate together. So you say, I'm going to write a brand new line of business app. It's a PaaS thing, and it can integrate well with my IaaS app as well. Or take my IaaS app and start to migrate pieces of it to PaaS as I continue to invest in it. And then we had this slogan that kind of guided the thinking. You know, when you work at a place like Microsoft, where we're working on Azure, and then we're working down the hall from the guys that write SQL Server and the guys that write Active Directory, you wouldn't believe, but the developers have this tendency to go, well, that's a really hard problem to support AD that way. Why don't we just go tell the AD guys to change AD so that we don't have to do that? And that's obviously not the philosophy that we want to follow. The philosophy of infrastructure as a service, no. AD is the way AD is. SQL is the way SQL is. Yeah, we can ask them to go make it better on our platform, but we've got to make sure that what is out there works, like SQL Server 2008 R2 or whatever it is, that thing could come up into Windows Azure and run without changes. So if it requires a developer, meaning if somebody needs to if you need to have a developer go modify your server application to work in Azure, then we failed. And that's what we set in front of us. Okay, let's talk about the images that we have available. You saw the platform gallery, and that's just a subset of the images. Actually, the best way to get a view of the platform and all of its details isn't the portal. It's actually PowerShell. How many people use PowerShell? So quite a few of you. How many people really love PowerShell? How many people use PowerShell, but it's like, PowerShell? So a few of you. Actually, I didn't use PowerShell much before working on Windows Azure, and I have to tell you, it's kind of grown on me. I kind of like PowerShell. Now, I know Jeffrey Snover's walking around here. He's the PowerShell architect. But please don't tell him that I said this, because he can be quite overbearing. When I run into him at work, which is quite often, every time I see him, he's like, hey, Mark, have you tried PowerShell? It's awesome. And so I just make it a point to go, no, Jeffrey, I haven't tried it. Yeah, one day I'll get around to it, I think. So I actually do kind of like it, but don't let him know. So you want to see what images we got available. Let me go up. I've got PowerShell up here. And I've got a little commandlet, or command line, that I've put together. And what this does is this commandlet will query the platform image repository, returning all of the images we have with all gory detail about them. Let's just run that one by itself. And what's going to come spitting out of this are lists of all the images, their categories, the descriptions. Take a look at some of the output here. So you can see, for example, here's one from the SQL Server group. All of the regions, in fact, our principle is every image is available in every region. Here's the label. This is SQL Server 2014 CTP1. So you didn't see that up in the portal, but here it is. So if you want to deploy the CTP Evaluation Edition of SQL Server 2014, you can already do it on Azure. There's the internal image name and a description. So this gives you tells you about expiration and so on. So this is what you can do with PowerShell. And here's a little command that, let me just run it, that will dump out all of the images. You can see that RightScale has put up a bunch of images, including versions of Linux that we don't have in our platform image repository that are supported by RightScale, not us. Or not by the Unix vendors, I guess. RightScale's signing up to support these things. BizTalk. You see a whole bunch of Canonical. And speaking of Canonical, how many people have used Ubuntu before? So it's actually one of the most popular Linux distros. And Azure a few weeks ago got, I think, some of the highest praise I've ever seen Microsoft get from outside of Microsoft. This one, actually, my jaw dropped when I ran into it. So Mark Shuttleworth is the founder of Canonical that makes Ubuntu. And back in 2008, when he started the Ubuntu distro, he created what they called bug number 1 in the Ubuntu bug database. And you know what that bug was? It's actually not a very nice bug. It was Microsoft is dominant in OS, with OS deployment. Microsoft's dominant. That's a bug from Ubuntu's perspective. So despite the fact that's a little kind of antagonistic, he closed that bug a few weeks ago. And the bug closure came with a note. Let me pull it up. Where's my... See if IE is going to be cooperative. So here it is. Comment for bug number 1 from Mark Shuttleworth, written on May 30th. And he says, blah, 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 I'm closing this bug because iOS and Android are now meaningful shares. And even though that's not really Ubuntu, we're going to kind of take credit for it anyway, just because I want to close this bug, I guess. But here's what he says a little bit later. It's worth noting today, if you're into cloud computing, the Microsoft IaaS team are both technically excellent and very focused on having all OSs, including Linux guests like Ubuntu, run extremely well in Azure, making them a pleasure to work with. Perhaps the market shift has played a role in that. Circumstances have changed, institutions have adopted, and so should we. So in bug number 1 for Ubuntu, the closure, Azure IaaS got a shout out, which I thought was really pretty cool. And that's why I honored him by creating an Ubuntu image in front of you as a thank you. Let's talk now about the server applications that are supported on IaaS. And let me explain what I mean by support. Support doesn't just mean, yeah, you can install it and it looks like it works. It means, yes, you can install it. Yes, the product team at Microsoft says it works. Not only that, but says it works well. Not only that, but says if you have a problem with the app on Azure, you can call the product team and they will support you and they will help you figure out what's wrong. And this is a list. We're working through all the product teams at Microsoft. You can see that there's some that are still pending. They're in validation phase, so those should come online soon. Our number 1 partner going through this, well, actually, our key target application was SQL Server. Of course, so many applications depend on SQL Server. Active Directory is another one, and SharePoint's another one, because SharePoint farms are extremely popular for line of business and enterprises, and so we wanted to make sure that, well, we support SharePoint, we support SQL, and if you support SharePoint, you've got to support AD. So we worked with those groups very early and then have brought in a whole bunch of others. All of these are fully supported applications from Microsoft on Windows Azure. Of course, I can't. Oh, actually, I can. There's other products, other companies that have signed up and said they support their products on Windows Azure. How many people heard about the hell froze over announcement from yesterday about that? Yeah? A few of you? What was that announcement? Yeah, Oracle said, we support Oracle DB on Windows Azure. And we said, we love the fact that we support Oracle too on Azure, from an Azure's perspective. So we've got this hell froze over moment with Oracle on Azure. But that's another example of a third-party app that is fully supported. Now let me switch to a little more technical tone here and talk about virtual machines and cloud services. Some of you may have gone to the portal, created a virtual machine, seen virtual machines node in the portal, which is your list of virtual machines, and then seen the cloud services node in the portal and think, oh, that's cloud services, that's not virtual machines. And this next section is to talk a little bit about what's going on under the hood, what the portal's showing you, and why it's showing you that, and how you shouldn't be confused, or how to help you not be confused as you run into this. Now, let me explain what a cloud service is. This is from a platform as a service perspective. When you go deploy PaaS app, you're creating a cloud service. And a cloud service consists of tiers or roles. And these tiers or roles have a common definition for the VM and the code that goes in the VM, as well as the configuration of those VMs, like what network ports they've got open, what size they are. When you scale out a tier, you're just creating more clones of that VM. So this web role can scale to any number of instances just by you going and saying, create another one, create another one, create another one. But these two roles then are like common units of management, the deployment and configuration, consisting of VM instances. Now I've got little labels here. Those are roles, and then these are instances of those roles that make up the cloud service. Because they're in the same cloud service, they are encapsulated with a container that is a management container. You can delete the cloud service, and that will delete all the roles and their instances. They're also inside of a network bubble. They can talk to each other internally as part of that network bubble very easily without you having to open ports up. So think of this cloud service as a container. Now, every VM in Azure is inside one of these containers. It's just that when you create a standalone virtual machine like I did, that you don't see the container. It's an implicit container. Let me go up and show you in that portal. So I created that virtual machine. And do you remember what I called it? I called it Y Linux, that's right. Okay, let's see if network is working. We can find, I'm in the virtual machine node. You can see I've got a whole bunch of virtual machines spun up, and we're going to look for My Linux. And, oh, Y Linux, there it is. Y Linux shows up here in Western Europe. If I go to Cloud Services, I don't see My Linux in Cloud Services, right? Nobody sees My Linux there? Actually, there is a cloud service called My Linux. If I go back into PowerShell and I say, get Azure service, this is going to return the list of services I've got for the subscription. Let me see if I'm in the right subscription context. Oh, and there it is. Here is My Linux, Y Linux. Now, it didn't show up in the portal. And because there's an implicit cloud service, what the UX guys decided to do is say, if you're new to the platform, we don't want to confuse you with the term or the concept of the cloud service container. So when you create a standalone virtual machine, we're going to hide the cloud service from you. If I add another virtual machine to that cloud service, let's go do that. Virtual machine, custom create, and, sorry, clicked on the wrong thing. Virtual machine from gallery. And let's this time pick a server. And I'm going to call this I'm going to call this server 2012. And this time I'm going to say connect to an existing virtual machine, and I'm going to connect it to Y Linux. And it automatically goes now to Western Europe, because that's where My Linux, or Y Linux, was created. And they need to be co-located in the same region if they're going to be part of the same cloud service, which is what I'm actually creating underneath the hood here. I'm going to say node availability set, and then press OK to create it. How long will it take to create this VM? It takes a little bit longer to create a Windows VM than a Linux VM. Windows is bigger. Windows goes through sysprep specialize reboot phase during provisioning, so it takes a little bit longer. Now, in the portal, if you look at the portal, because of some delays that we're going to get out of our notification system, it'll take about 5 to 6 minutes for that VM to show up and be ready, and me be able to connect to it using the portal. Underneath the hood, that VM is going to be ready in about 3.5 minutes. So if somebody wants to start a stopwatch and remind me in about 3.5 minutes, we'll go see if I can RDP into that VM and see if it's ready. The other thing that we're going to see is as that VM gets past the provisioning phase, Y Linux is going to pop out into a visible cloud service. And the reason that the portal was hiding it, by the way, is that when the portal created it, it put in the description implicitly created hosted service, you can see right here, which it does when you create a standalone VM. Let's go back and see if, and there it is. Boom, Y Linux showed up right there. And if I click on Y Linux now, we're going to see that there's 2 VMs if I go to the Instances tab, well, the second one's not even part of it yet, but the portals already knows that that second VM's on the way, so time to expose that what was hidden before cloud service. So, and actually it just showed up. There's Server 2012 starting up. So that is the explanation behind the difference between cloud service and the standalone VMs that you'll see. It's a UX construct. It's not a platform construct. It's aimed to try to reduce confusion. In my opinion, it maybe does the opposite, but that's just my opinion. Let's talk about now the images versus disks. When I went and created that virtual machine, you saw that I had a list of images that I could pick from. And those are what we call generalized images. They're images that are ready to be cloned. For you to be able to say, I want to create a VM, start with that base. And then what happens during the provisioning process is it gets personalized. Just like any sysprep specialization, define an administrator account name, give it some other attributes, and it's ready to go. That's opposed to and what actually gets produced by that process of me creating the VM is a disk, which is a specialized object. It is unique. Yeah, you can clone it, but then you're going to end up with VMs that look exactly like each other, which isn't necessarily what you're after. It's just like cloning on-premise VHDs. You can clone them by copying them, or you can spin up the VMs, syspreps, generalize them and shut them down, and then take those and then spin up new VMs that will get specialized during provisioning process with unattend.xml ISOs or whatever you inject in there to get them specialized. So disks, think of those as specialized. And now I've got a bunch of disks that I've created. For every VM you create, you get a disk, which is the OS disk. And if I go to the VM tab, you can see your inventory of disks. And I've got lots of disks. Let me see if I can find, well, actually let the portal, when you create one in the portal gives you a name automatically. And here's the disk that was created. You can see it, it appends the service name, then the VM name, and then some GUID, kind of a string that it attaches to, assigns to it. That is the OS disk for the Linux VM. I also can create data disks too. And the number of data disks that I can attach to a VM varies on the VM size. Here's a chart that shows us all of the VM sizes we currently have in Azure, starting with extra small, going to extra large. And back in April, when we GA'd Infrastructure as a Service, I'll take questions at the end. Oh, pardon me? Oh, 3.5 minutes. Oh, cool. Thanks for reminding me. 3.5 minutes. Let's go see if that server is ready to go. So let me find him back in here. Server, where is it? Server 2012. So it still says running provisioning here. If I go to actually dashboard and I get the IP address, I'm going to show you something. Public IP address. Crap. So hard to copy and paste from here. Let's see if I can remote. And I've got to give it what's called an input endpoint, which I'll explain in a little bit. Okay, let's see if this thing is ready. And it is. And my account was /Abby and foo bar and bingo. I'm RDPing in, so a little over 3.5 minutes. Probably was ready a little bit early, probably almost exactly 3.5 minutes. And there we go. So I can tell you unequivocally that we have the fastest Windows virtual machine provisioning on the planet. If you go deploy on EC2, take a look at the comparison. The portal, of course, like I mentioned, we've got some delays in reporting the status up into the portal. So if you go into the dashboard, this it'll probably come up in a second and say that it's not quite ready yet. But you can see that it is actually ready, and we're already pinging into it. for the first time. Okay, where were we? We were talking about disks. So then you can see that there's two VM sizes that I've got at the bottom that have weird names, A6 and A7. Those are the new ones we released back in April, and those are large VMs, larger than the other ones. We can call them high memory VMs, essentially. If you look, the ratio of RAM to CPUs is higher than on the kind of standard VMs, up to 56 gig. And the reason that we call those A6 and A7 is that we realized that this relative naming thing based on all of the characteristics of the VM being tied together is just not sustainable as we go forward. And you can see if you look at Amazon's naming structure that they've got a problem, because now they've got like super duper extra quadruple large high memory with high IOPS with quad super networking, and we didn't want to get onto that treadmill. So what we're doing is moving to this generic, hey, it's a label, and then our portal and UX and documentation can help you find the VM that's right for you, but we're not stuck in this. And what's high memory today is not high memory tomorrow. It's actually going to be small memory in a few years. So the names, these relative names get very stale. So anyway, that's a little digression on the names. Now the disks column here, the number of disks, data disks you can attach to the VM, as you get up to the larger VM sizes, you can attach up to 16 data disks to a VM. I've actually got a PowerShell script that creates a VM with as many disks as it can put onto it. In fact, well, actually, only 15 disks. If you count that, and this is PowerShell pipelining, it's one create VM with 15 pipelined add disks to it. So this thing, and those disks are 1 terabyte in size. So it's the maximum disk size that we support. So this VM has a local OS disk plus, or an OS disk plus 15 terabytes of data disks attached to it. I've deployed that VM just before the talk, and that is called IaaS Server 2012 16 terabytes here. And down here, you can see all of the disks attached to it. The problem is that it only has 15, not the full 16. So let's see what it looks like to actually attach a disk to it. We're downloading the RDP file, and that RDP file should come down. For some reason it stalled. We've got networking issues. Hello. Let's try that again. While it's downloading that, hopefully, I'll go ahead and attach a disk to it. So I'm going to attach an empty disk. How big is 1 terabyte in gigabytes? Anybody? Anybody? Bueller? 1024. That's a good guess, but it's not, according to the portal. Yeah. See, the size has to be between 1 gigabyte and 1,023 gigabytes. The portal definition of a terabyte is 1,023. So not that I agree with that definition, but that is that's a point of view, as we like to say. And so let's attach that disk, and I'm waiting for my RDP file to come down from the portal. Eventually, let's go try IE and see if it'll give me the. Where's IE? Okay. I guess I got slammed with a whole bunch of them. And I think for this one, I had Mark Russ. Actually, let me take a look at that PowerShell script. Where's the username? Username. Where is it? I actually added it. I had to add it dynamically because I didn't specify it. So what we're going to see when we get in there, and I apologize for the delays here, is 16 disks, or maybe 15 if the 16th one hasn't yet arrived. but this will be dynamically attached to it. Let's go back to the virtual machine. And I don't know that successfully created, successfully attached. So according to the portal, the VM is attached. According to this, I'm having trouble connecting to it. So we're going to go ahead and move on, maybe come back if we get a chance. Something to note about the disk's behaviors is that there's two different types of disk behavior. There's cached and non-cached. The OS disk is cached for performance because there's a lot of small I/O reads and writes as the OS boots, but data disks are uncached. So tip here is if you're going to have a database that's of any size at all, you're going to get better performance by putting it on a data disk. Do not put it on the host OS disk. Of course, it'll work, but you'll get much better performance, and this is working with the SQL team. Guidance is put your big databases, your heavy databases, on a data disk, and you'll get better performance because you'll go right back past the cache. Now, what do we use underlying the storage is Windows Azure storage. Like I mentioned, we bet our IaaS storage for VHDs on our platform as a service solution. And here I am, and let's open up Disk Manager. And here we're stamping out all the disks. And that 16 disks did show up here, so it's in that list. So now I've got a whole bunch of disks, and what I can do at this point is create a new striped volume with all of those disks to basically get one massive 16 terabyte disk. Let it be drive A. Now here's an important tip. You must check this. And then this is yes. And in a few seconds, we're going to have a 16 terabyte volume attached to that VM. That volume and all those disks are backed by Windows Azure Storage. Windows Azure Storage is highly available, so there's 3 replicas durably written to each data center, to the local data center where that VM lives every time there's a write to the disk. This means we can tolerate multiple failures and not lose your data. This is a promise that we make unequivocally. We will not lose your data under any circumstances if the write was flushed or written through back to storage. Go read the fine print on elastic block storage, and you'll see that they're a little fuzzy about that. There's also something else you get with Windows Azure Storage, and that is that we do replication across geo regions, pairwise data centers. So there's asynchronous replication going on. So you won't necessarily get a point-in-time copy of a VM's disks if there's a data center failure, but you will get your data back in some form up to, usually lag is about 15 minutes. So you've got that. And let me just highlight the power of this solution using this Cloud Explorer tool, which is an off-the-shelf Windows storage utility, which just plays with Windows storage blobs. And here's my disks for those large VMs. That's actually it's here. Here's those disks that were created by that PowerShell script. Now, you can copy them down to your local machine. This is one way that we promise that this image mobility for our VMs is you can take the host OS disk from a VM up in the cloud, copy it down to on-premise, and fire it up in Hyper-V, and it'll just work. The same thing. Take your VHD from on-premise, copy it up to Azure, import it as a disk using the PowerShell commandlets or the portal, and then you can launch a VM off it in Azure. And we've got super quantum copy technology that makes it incredibly fast to copy one of these things. Watch me take one of these disks right here. I'm going to take it. I'm going to do Control-C, and I'm going to Control-V it into here. The network is going to behave. Okay, well, try a different folder. Nope. Come back in a second and I'll show you how long it takes to copy that 1 terabyte of disk. What, pardon? No. So how many people think, just before we do this, how many people think it'll take more than 30 seconds to copy 1 terabyte? Okay, well, let's come back and see, hopefully, when this thing comes back. Let me actually try relaunching it. All right, network is definitely, it's coming in spurts. It looks like the network sometimes works, sometimes doesn't work. All right, let's move on, and I'll come back to that because that's a pretty cool demo. All right, virtual machine availability. I mentioned that we have high availability support in the platform as well, and our high availability, our SLA that we promise for our platform as a service is 99.95% availability. This means multiple role instances. When you create a worker or web role, multiple instances, at least 2 instances, gives you that 99.95%. That means that you will be able to access from the internet one of those 2 instances 99.95% of the time. If you can't, then we've missed our SLA and then we reimburse you. And of course, our targets are higher than that, but that's what our customer promise is. What's included in that is all of the things that are our fault. Hardware failures, network failures in their data center, hardware upgrades, planned maintenance. So we do maintenance on the servers. What part of the maintenance we do is upgrading server. We patch the host OS. It is stock Windows Server 2012, and once a month we go and roll out security fixes, just like anybody that's managing their own data center and wants to stay current with patch levels. We do that. So we take down the VMs that are on the servers when we patch them and then bring them back up. We do it in an orchestrated way so that if you've got 2 instances in one of these PaaS things, we don't do it at the same time. We take down one server, patch it, bring up the VM, then take down the next one. So one of those 2 instances will always be online. How does this relate to IaaS? In IaaS, if you've got a single instance, today we do not have an SLA behind it, a single instance. Neither does Amazon. If you add a second instance and you put them in what's called an availability set, you're signed up for that SLA. We will guarantee that one of those 2 instances will be up 99.95% of the time. This goes across the hardware upgrades as well as our server OS or host OS updates as well. And this will allow you to deploy high availability solutions like SQL Always On or SQL Mirroring, like you see here. How do we do this? We've got the concept of fault domains and update domains. And this is what's visible to you in the portal. A fault domain is a single point of failure in our data center. So we've got physical machines there in that rack. There's a single point of failure, the power unit rack switch. If that fails, then all those servers die. So what we do is create, 2 things, the power unit, the PDU, as well as the top of rack switch. Those are 2 separate components. If either of those fail, we lose the servers on that rack. So what we do is when you create a fault domain, when you spread your instances across a fault domain, which you can do by putting them in an availability set, you can see that those 2 VHDs have been put in 2 different racks. So we then tolerate any single point of failure and maintain the 99.95% SLA on that availability set. We also, like I said, orchestrate the host OS updates to those servers to preserve that as well. Let me show you in the portal a high availability application that I've got deployed, assuming the network is going to. Okay, so let's see if my 16 disks here come back. Painful. Let me see if I've got this application. It's the front end for an IaaS multi-tier application. This has 2 IaaS front ends, and those IaaS front ends I've got in an availability set. Because they're in an availability set, you can see that each of those instances, Web Apps Manager 1 and Web Apps Manager 2, are in 2 different fault domains. And that means that they're in 2 different racks. I've even got here a backend for that IaaS application that includes SQL Always On. Here's SQL Always On instances plus the SQL Always On witness. And you can see that because these are in an availability set, they're in 2 different fault domains. And you can see that they're in availability set when I click on it and I say configure. This is the SQL Hadron availability set, and I've got all 3 of those instances in there. Now, when we do a host OS update, we'll only take down 1 of those at a time. They'll also be spread across at least 2 racks. So if we have a rack failure, we'll lose at most 2 of those, not all 3. And the way that we spread them, here's the, for a PaaS web and worker role, we put the instances on racks. We put them in update domain and fault domains. And when you create an availability set with your virtual machines, you get that same kind of topology spread across the racks. Plus, they get put in different update domains. An update domain is what the host OS update honors. Let's see if my copy will work. OK, let's try that in. Copy. And, all right, we'll come back. Eventually, by the end of the session, we can maybe copy. And hopefully the 1 terabyte copy fits within the time that we've got left at the end of the session to show you that. I mentioned earlier, when I talked about platform as a service, that in PaaS you use the runtime APIs to discover names of VMs, or IP addresses of VMs. We introduced DNS, Windows Azure DNS, as part of supporting these virtual machines. You get full control over your machine names versus the machine names that platform as a service VMs get assigned. You have no control, and they've got funny names like RD01756. In IaaS, you saw I assigned my machine name. DNS services are available to those machines so that they can find each other on the network. You can also bring your own DNS server if you'd like to. So you can use your on-premise DNS server, deploy a DNS server into Windows Azure and point at your VMs at that for lookup, or use a public DNS service as well from Windows Azure. As part of this release, we also added support for UDP because lots of server applications use UDP instead of TCP, which is the only thing we had before. We also support dynamic ports as well as ICMP now as part of this release. So all VM to VM as well as UDP into the data center and out of the data center. And then there's 2 concepts that we've added that I'm going to delve into: port-forwarded endpoints as well as custom load balancers, health probes for infrastructure services. All right, so here I'm going to go. I'm going to press Control-V. Did you blink? This is the one that I just copied. And it copied in less than a second. And it's not because that that disk was empty. Even if it had been completely full of data, it still would have taken that amount of time. And that's what's called quantum computing. I'm just kidding. It's not quantum computing. It's called copy-on-write computing, which is a little more familiar to you, many of you probably, which is we're inside the same storage stamp, same collection of servers managed as a whole. So we get this benefit of copy-on-write copying between blobs. That means that this is actually taking up almost no space, and I will not be charged for additional space. In fact, note about the charges for disks is that you only get charged for the amount of the disk, the amount of the blob that is actually committed. So because those are basically raw VM or raw blobs right there, they're probably just taking up a few kilobytes of space, a few megabytes of space, and that's all I'm going to get charged for on my bill at the end of the month. And for that second copy I made there, I'm probably not going to get charged anything because I haven't modified it off the base image, so it's sharing all the storage with that initial image it was copied from, and I only pay the price once for that storage. Okay, back to port-forwarded endpoints. With Platform as a Service, we added RDP support, like you know, and you can RDP into any VM as part of your cloud service. The way that we implemented that is putting agents into the VMs that are port forwarders. So when you RDP into one VM, the RDP port forwarder says, oh, you're not wanting to talk to this VM, you're wanting to talk to that VM, and I'm going to forward the RDP traffic over to it so that you RDP into that one instead of this one. We couldn't put agents into IaaS VMs. That would break our promise of image mobility. You don't put agents in your Hyper-V VMs. They just work with the integration components that are already installed there. We wanted to make it so you can bring those Hyper-V agents up into Azure, still be able to RDP into them, without having to inject an agent into them. So to enable this, we define port-forwarded input endpoints. Another aspect of the cloud service is that it's a network bubble and it gets one IP address. And that IP address is shared by all of the VMs in that cloud service. So how do you uniquely address one VM behind a shared IP address? You do so by assigning ports, a port mapping from an external port on the virtual IP address, that shared IP address, to a port on the VM that you want to talk to. And that's what port-forwarded endpoints do. Let's go take a look. I've got that Fabricam Cloud app with the two IaaS front ends. Let me pull it up. Cloud apps. There it is. And this is the public IP address right here, 137 whatever. There's the DNS name right here, Fabricam Cloud apps. If I click on instances, you will see, and I click on one of them and click on endpoints, you will see that I've got 3 publicly mapped endpoints on this VM. And the portal is telling us the protocol of the endpoint, which could be TCP or UDP, the public port, and the private port. What's the public port? What's the private port? The public port is the port on that public IP address. The private port is the port on the VM. You can see that RDP, the port on the VM, is the standard RDP port, 3389, but it maps to a public port, 55182. When I RDP to Fabricam Cloud apps, let me go back and get that a DNS name. When I connect to this, 55182, what I'm doing, is actually RDPing through that public IP address to port 3389 on that VM. And that is because our software load balancer is forwarding incoming port traffic to port traffic aimed at a particular port on that VM. And that is the way that we achieve this individual VM addressability. If you take a look at these other endpoints, there's another one here, web, that is not port forwarded. If it says no here, it's port forwarded. If it says yes here, it's not port forwarded, it's load balanced. And that means that the load balancer will spray across these ports of these VMs that are part of the load balancer, which I'll talk about in a second. And that's how we achieve this. And it's going to be too bad if I can't connect to VMs here. All right, let's continue on and talk about load balance sets, which we touched on right there. I've got 2 IaaS front ends. I want them to be load balanced. I want traffic that comes from the web to get sprayed across both of them. In Windows Azure, you don't need to set up your own load balancer. We provide load balancing as a service. For PaaS, you get it just as being part of a role. If you've got a public port on the role, it'll get load balanced. For infrastructure as a service, what you do, okay, well, you can see that I'm RDPing into that particular VM. I'm not going to actually follow through with that and waste our precious network on that demo. I'll save it for a later demo. But one of the things that the way that you get load balancing for infrastructure as a service is to add those VMs to what's called a load balance set. And a load balance set then will have the load balancer spray across the front ends. I've got a demonstration of that very clearly here. The difference between the load balance sets and the port forwarded endpoints with a pretty cool cloud app here. It's called IaaS Load Balance Demo. And if I click on this link, I get taken to one of the VMs that are behind that cloud service, and the VM advertises which one I got to. here because the load balancer forwarded it to one of those particular VMs. When I go take a look at the VMs in that cloud service, go to instances, you can see that I've got 6 VMs. And if I click on one of them to look at what its endpoint configuration looks like, it's got a few. And the ones that I'm going to focus on here are this one, which is the load balance one. Public port HTTP 80 maps to internal port HTTP 80. And that's what we went through there just to hit that VM. But we got forwarded by the load balancer to one of them. And then I've also added a direct HTTP endpoint here so that each VM can be addressed uniquely using port forwarding. And I'll demonstrate that by coming back to this and putting 3005, which will take me to VM number 5. And that's with port forwarding. Again, if I get rid of this and press F5, I'm going to get different VMs because the load balancer is using a 5-tuple. Local port, client protocol, client IP address, remote port, remote IP address. That 5-tuple is what determines which VM you get taken to. If Chrome used the same source port for every one of these, I'd always get connected back to the same VM because there's a consistent hashing algorithm that's used by the load balancer. But because there's a different unique local port on every one of the times I press refresh, I get taken, well, you saw that time it reused the same one, but I get taken to a different one. So that's an example of port forwarding and load balance sets. And here's just an example of load balance sets and how you get sprayed across, which gives you scalability as well as availability. The other thing you can do with IaaS is add custom probes, which I won't get into, but you basically say, hit a particular URL on those, and the load balancer will determine if the VM is healthy. So the load balancer will take a VM out of rotation if that server that the VM is on dies, or if the VM dies, or you can have your custom health policy here implemented on the web front end to say whether or not this VM is healthy and should be receiving traffic from the load balancer using these custom probes. Spend a few minutes here talking about cross-premise connectivity in Windows Azure Virtual Network. So with Windows Azure Virtual Network, I can overlay a subnet on top of a collection of virtual machines. And what that does is make the virtual machines visible to each other using these IP addresses that you provide, which enables a few different scenarios. One of them is that I can take 2 cloud services, which normally can't see each other because they've basically got their own private network bubbles, and overlay them into a virtual network so that they can see each other. And that example is visible right here with this back-end, front-end app that I was showing you. I've added them to a VNet. And there's Web Apps Manager 1, Web Apps Manager 2. They're part of this app VNet. And they're part of the front-end subnets. So I've assigned them to a range of IP addresses that they get their overlay IP addresses from. So these guys actually have 3 IP addresses. They've got the public IP address that we looked at. They've got the IP addresses internally of the VMs, which you'll see when you go look at the VM configuration. And they've got these overlay IP addresses. These overlay IP addresses make it possible for the VMs from different cloud services to talk to each other using those IP addresses. And if you look, the backends, there's SQL servers that they talk to. They're part of the backend subnet, and they get their IP addresses pulled from that subnet IP range. Because they're all part of the same VNet, they can all see each other. So Web Apps Manager 1, if I ping SQL on 1, this IP address, and I'm afraid of trying to even connect to those VMs, given the network connectivity problems I'm having, like that won't even come up, then I'd be able to ping that. Actually, I'll show you a demonstration of that in a second as I show you a demonstration of something else. Using these VNets, I can then create application topologies where I've got my front ends on the open internet, my back ends aren't. And that's exactly what's going on here. Those SQL servers don't have a public IP address, ports open, but the front ends do, port 80, so traffic can talk to them. Those SQL servers and the domain controller that they're associated with are sitting inside the same VNet so that the front ends can talk to them, but those back ends aren't visible on the open internet, and that protects them. Then what I also can do is add a tunnel, a VPN gateway, which I've done with that app. So with that app, the topology of that app is that there's a domain controller up in the cloud that you saw as part of that back-end subnet and part of that back-end cloud service. I've got that whole VNet gateway joined to a machine back at Microsoft where there's another domain controller sitting in there that serves as the on-premise domain controller. So there's two sites in the domain. And the VMs, when they're in the cloud, try to talk to the cloud site. And if that's not accessible, they'll talk to the on-premise site. You can imagine this is part of my CorpNet AD, so the same thing applies. If the CorpNet domain controller is accessible, then everybody talks to that. Otherwise, they'd go try to talk to the cloud one. So I get some kind of high availability for a domain controller across the cloud and on-premise. I've also got a point-to-site gateway, point-to-site subnet configured as well, which you saw me demonstrate in the keynote. I'm going to connect to that gateway, which I installed the VPN client for, at VNet here. And once I've joined it, then those machines are visible to me as well. And let me see if, networking-wise, I can connect to one of them. And there, wow, that was amazingly fast. Thank you. And now I'm inside that web front end. Now what I can do from this web front end is actually, and you saw that I hit it using that overlay IP address because now I'm part of that VNet. This machine that joined that VNet, and those IP addresses became visible to it. What I can do now is remote back in to the gateway that I've got on premise. And I'll show you that not only have I set up this gateway under somebody's, on a box back in the lab, but I'll show you what the VPN gateway device is and how it's configured. And this is something we just released a few weeks ago, support for this. And that is, here I'm actually RDP'd through the cloud into a server. It's actually a virtual machine sitting on Hyper-V back in a lab at Microsoft's campus. This is the VPN gateway that has connected the on-premise domain controller to the cloud, and I'm using actually remote routing and access, RRAS, here, and I've configured it to point up to the Windows Azure gateway. If you look at this IP address right here, that is the gateway IP address that I got assigned by Windows Azure when I said attach a gateway to this VNet. And that comes, and that's visible up here in the portal right there. So using RAS on Server 2012, I now have a VPN gateway from on-premise into the cloud. And also from here, I can RDP into the domain controller on-premise, which has got its address is .10. And you'll see that once I'm attached here, that the domain controller on-premise will have all of those machines that are in the cloud. Here's SQL 1, here's SQL 2, or SQL always 1. SQL on 1, SQL on 2, Web Apps Manager 1, Web Apps Manager 2, all part of this domain that's got a domain controller on-premise, as well as one in the cloud backing it. And you see these DC1 actually got two domain controllers up in the cloud for high availability in the cloud as well, that are part of their own availability set, part of the same VNet. So I've got multiple cloud services, part of the same VNet, high availability across everything, including back to on-premise. So I've just got to wrap it up here. I was delayed a little bit by network glitches, so I'm just going to quickly talk about the vision to wrap back to the beginning of IaaS and PaaS and what we've delivered as part of this first wave, as we think of it, of IaaS features. PaaS, we believe, is the future. And so we want to make sure that we enable connecting PaaS and IaaS together. And there's a few ways you can connect them together. Here's some example architectures. And that is, look, over time, that application that I showed you with the web front ends on IaaS, the back ends on SQL Server, that's a very simple kind of application that I can migrate slowly at my rate to PaaS. Let me show you that application and what it looks like here, the front end of that application. So it's the Events Manager app that you saw me demo in the portal. And if I say Mark Russ and I log in, what this thing is going to tell me is the connection string to the back end. It's the machine name of the front end that I connected to, as well as the back end SQL connection string that it's got. And you can see here, it's Web Apps Manager 2 is the front end that I got directed to by the load balancer. And I'm connected here to the connection string of the SQL Server. Actually, that didn't display the whole string, unfortunately. Did I connect to the right one? Which one did I connect to? Getting lost in, yeah, okay. So now, the next step is to take those front ends and move them to web roles and then let them talk to the SQL Server, because the easiest thing to migrate to PaaS are stateless IaaS front ends that are built on ASP.NET or MVC4 or even other types of web servers. And so I've got this version of the app, and if I click on it, it is actually a PaaS version of the same app, and it's going to be connected back to the same database. When I click on it, you'll see the same interface. It's authenticating me to the domain controller because I've got it also domain joined, so it's Fabricam Mark Russ that I'm domain joining at. And let me show you how easy it was to take that app and migrate it to PaaS. This is the app. You can see here's the title of the front. I can right-click and I can say, Add Windows Azure Cloud Service Project. What this does is wrap this MVC app in a cloud service package. And at that point, you can see it's now a web role, which is exactly how I deployed that second instance up into the cloud. And now I've just taken the IaaS front ends and made them a PaaS front end. And you can see that the machine name now is assigned by Azure, not by me, because with PaaS, you don't worry about the virtual machine names. And then the final step, and those are connected with VNets as well, and the final step is to take the whole thing and make it PaaS, which I've got right here, pure PaaS. So I've got the same app, and this is the last thing I'll show you before we wrap it up, because I'm a little bit over. Pure PaaS version of the application, which is now not talking to that database, those SQL backends, still domain joined, but it's actually talking to a SQL Azure database, a Windows Azure database. And you can see here's the Windows Azure database connection string, which is different than what you saw with the SQL connection strings from the IaaS versions of those, or from the ones that are talking to the SQL IaaS versions. So that brings me to the end, just to show you that we are committed to this migration from IaaS to PaaS. If you look over this set of feature or requirements that I set out at the beginning that we said we wanted to achieve, I think you'll probably agree. IT Pro experience, PowerShell, heavy PowerShell support, heavy support for IT Pro scenarios, support for key server applications, SQL, Active Directory, SharePoint, BizTalk, storage manageability, using Windows Azure Blob Storage so you can migrate blobs back and forth from the cloud, VM images, VM disks, high availability features with the availability sets, which get you fault domains, which get you load balancer support, advanced networking, the VNets that you can connect cloud services together with, as well as the point-to-site, which I demonstrated, as well as the site-to-site, which I also demonstrated, integration with compute paths in various ways to let you migrate to the future. And with that, I want to wrap it up, and thank you very much for coming and bearing with my network issues that we had along the way. I hope they didn't interfere with you me getting across how I think comprehensive we got this first set of IaaS features. And make no mistake, we are continuing to evolve not just PaaS like I've been talking about, but also IaaS as well. There's ongoing features released that we're going to be coming out over the next few months. So the cloud is kind of this journey that we're all on, and there's no big bangs. I think very rarely you'll see big bangs like we just saw with IaaS, which was a massive release that took us a couple years to get out. But now what we can do is incrementally add more features to support the things that you want to do. With that, I thank you very much. If you want to go deep behind what's going on under the hood, I've got a session this afternoon at 3:30, I think. It's Windows Azure internals, and I talk more about the underlying disk architecture for IaaS, if you're interested in IaaS specifically, but the way that we architect our data centers under the hood with software and hardware. So I hope to see you there. And then Friday, I've got a couple of sessions that are a lot of fun on Windows. And thank you very much. Thanks for coming, and I hope to see you later today or later this week.